Good evening, this is Christopher Schott. I'm in the Engineering 1315 D01. This is my semester project right here, and here's all my components for that project. Here's a rough diagram of my pulley system. Here's some of my components drawn out. Here are my frame pieces, the cord that I will be using during this process, the screws, the bolts, the pulley, my first object, my second object, and my third object that I will be weighing, my scale, and my screwdriver and wrench, and also the tape measure to figure out how long these cords are. And then here's my final diagram of the project and what it will be doing. As you can see, I've just built my frame to my pulley system. I have 4 bolts I have 4 screws with 4 nuts. Here's one of them, here's the second, here's the third, and here's the fourth. And this is the frame, to the pulley system. And I'm moving on to the next step, which is to add the pulley system, or add the pulleys. Okay, so I've finally finished up setting the pulleys. It's a double pulley system, as you can see. Here's one of the pulleys, here's the second pulley. This one's fixed. It's a single point, it's a single leaf fixed pulley. This is a movable pulley, but this makes a double pulley system, which I will attach weight down here on this string, and then pull the weight using this string. Okay, so here I'm going to weigh all 3 of my objects. The first one's going to be the chest piece. So turn it on. It is reading 0.113 or 1.13 kilograms. Okay, so I've already attached my my band to measure the weight of this object. .19 kilograms. Alright, the final piece to be measured or weight determined. .13 kilograms. So here's the final step of the pulley system and the whole project. I plan on to attach each 3 of these weights to the pulley and show the force that I use to pick it up. This weighs 13 kilograms, this weighs 19 kilograms, and this weighs 1.13 kilograms. Small weights, but for what we needed to do, good amount. Okay, so I'm about to show you how much it takes for me to lift this object and how much force it takes to do that. So the force taken to lift this chest piece is 0.05 kilograms. And every object that I decide that we are lifting today is going to go to the top point of the pulley system. The difference is every distance, or each time we raise it, we're going to be measuring from the bottom of this. Tape measure. So we pulled about 16 inches. And at the tallest point, So from the bottom of this object, it's about 15 inches from the ground. Okay, so we already did the measurements, so you didn't have to see me struggle through the process of tying it up and doing all that. So when I pull this length, it is 17 inches, and when I raise it all the way to the top, this is 16 inches. And now the force used to lift this object. $13 kilograms. That was the force that was used to lift this object. So for the line pulled from this distance to here, it is 14.5 inches. And then from the bottom of this to the base of this, it is 13.5 inches. Now I'm about to show how much force it is to use, or force used to lift this object. .02 kilograms, and that was the force used to pick up this object. In conclusion, the double pulley system allows me to lift heavier objects with minimal force. This is the mechanical advantage of a double pulley system. Thank you for